Okay, so what we did today here is we looked at problem 57 off of the review. It says a ball is tossed upward. Its height after t seconds is given in the table. Find a quadratic function to model the data. Use the model to determine when the ball reaches its maximum height, as well as the value of the maximum height. So what we did was we went to the calculator, went to Stat, went to Edit, and if you have anything, remember we push up here and push Clear. When you come down, that list will be cleared off. So we went and put the x's in the first list. We put the y's in the corresponding list 2. Once that's done, we quit out of there. We will run back to Stat, this time not Edit, but rather Calc, and it says find a quadratic function to model the data. So what we're going to do is we are going to go down to quadratic regression, and your calculator may look a little different here, but as long as you've used list 1 and list 2, you may just push enter on that or calculate, whichever one you see. And here it tells me the A, B, and C for this quadratic equation for this data. So I'm going to set the calculator aside here for a second and write up here that the equation is y equals negative 16 x squared plus 50x plus 5.5. Now I'm actually done with the calculator portion of this problem, because now we had a formula called x equals negative b divided by 2a that we can use to find the maximum point. This case b is 50, so the negative of 50 divided by 2 times negative 16 means that negative 50 is divided by negative 32. I will bring the calculator back in here to figure that out. Negative 50 divided by negative 32 is 1.5625, and that is the time that the ball reaches its maximum height, and the distance that it reaches is what we get when we plug that value back in here. So on the calculator screen here, I'm going to try and make all this show up. I'm going to go negative 16 parentheses 1.5625 parentheses close squared plus 50 times 1.5625 plus 5.5. And the result of putting that back in is a y value of 44.56, and I have to look and see feet. So about a second and a half into this event, the ball reaches its maximum height of 44.56 feet. I think the one that matches the closest to that is 44.6 feet in 1.6 seconds. So the answer is B.